the way you get this thing running, watch carefully because it's very complicated. You're going to get the zip file. You double click it, and you're going to see 3 files in that directory. One says Linux, one says Mac OS, and one says Windows. You're going to double click that, which will unzip the file. Make sure it unzips the file. That's really loud. Make sure it unzips the file. I think on Windows, if you double click it, it doesn't unzip the file. It just opens it up in a new screen, and then you got to like drag it out. And after you know for sure 100% that it's unzipped, you can double click that, and there should be an executable called either DragonRuby exe, DragonRuby, or if you're on Linux, what the Linux version is. And you should be able to double click that. And if you get this and you're on a Mac, just right click and open for Macs. And this screen should come up. If you can get to this, you have installed DragonRuby. That's what it takes. You got it working? The unzipping part is complicated.
Well, I had the unzipping part. I was just looking for the README file to say, just double click it, dude.
Oh, no, that's a good point. I should probably put that because people expect like some kind of installation process or something, or manually editing the registry, some other things for the developer tools, right? But you should be able to just double click it and it should open. Okay.
But now we need to read the README text.
But now you have to read the README text. But don't read the README text. We're just going to get started.
Something you'll find useful if you go to our website. There's this new link called Tonight's Materials. Click on that link. You'll need that in a minute. This will be some of the sample code that you will use tonight.
And the zip files. You need to have some text, some form of a text editor. It doesn't matter really what. You just have to have one. You won't get syntax highlighting if you don't, but if you're just like using notepad.txt or Notepad, you can use that to open your file. But you want to be able to open a file. And so this is the next step that you want to take for those that have got the app, have everything downloaded and running. Okay? You're going to see a folder in there called My Game. Does everyone see the My Game folder? All right. And in there's an app folder. And in there's one file, main.rb. Okay? And what you want to do is you want to open that file up and just type these lines. That's it.
So main.rb already has 3.
Remove all the lines in main.rb and then replace it with just these lines right here. And the moment you save, you should see a blank screen. Yeah, make sure DragonRuby's running. You don't have to stop running the application.
I'm gonna try to adjust the lights real quick.
Sounds good. Thank you. You should see a blank screen. Do most people see blank screens? Sweet.
Is that okay?
Yeah, that's fine. Congratulations, you are all game developers. If you were able to have this app running, edit the file, save it, and see a blank screen. This is a very good sign. Okay. So here's what we're going to do next. We're going to turn the blank screen into a different color. All right? And remember, you're going to My Game. App main.rb. Okay, this is where you're going to put the code, and you should see a blank screen. Hopefully everyone sees the blank screen. I'm going to be very excited if everyone eventually gets a blank screen. Okay, so with the blank screen, we're going to make the screen not blank. The way we do this is hopefully straightforward. This right here, this thing right here is a variable, or it's a method parameter. And what we're going to do is we're going to do this. We're going to do args dot outputs. So in a computer, you have inputs and you have outputs. So this is an output. And one of the outputs is called solids. So like a solid color. And then we're going to use this fancy little symbol here. That's the concatenation symbol for Ruby. And we're going to give it 4 values in a list. The 4 values are going to be the X and Y position, and then the width and the height of our solid thing. When you save, you should see a black screen come up. Again, you should be able to just have the game engine running, and you should be able to just see the black screen. An interesting thing is that if you mess up the syntax, DragonRuby will tell you what's wrong. It'll say, hey, you got a syntax error. You need to fix it. Okay? And then the moment you fix it, DragonRuby is happy and it goes away. All right, so args, A-R-G-S, which is short for arguments, dot outputs, inputs and outputs. This is an output, and we're sending an output to solids. So imagine a solid shape, a solid rectangle. And we're giving this thing a list, which is the X position, the Y position, the width and height. Everyone see that? Cool. Okay. So now we're going to create another solid, and we're going to put it in the center of the screen. Okay? Everything in DragonRuby is based off of these XY positions. You have 1,280 pixels across and 720 pixels up and down. That's it. Always and forever. Okay? So to put something in the center of the screen, you divide both things by 2. 640 by 360. And when you save the file, you will get another black rectangle in the center, as you can see. The contrast is bad, right?
It's great.
So the fun thing, though, is that you can give this thing, you can give DragonRuby, you can give the solids outputs a few more parameters. And sorry, I made a mistake. The X position should be 640. The Y position will be 360. And we're going to make this thing just 10 by 10. Now, the next 3 parameters that you can pass to it are the color. You give it your red saturation, your green saturation, and your blue. And by doing that, you should see a tiny white square in the center of the screen. You can change the size. We can make it 50 by 50, make it bigger. 10 by 50 will do that, right? Makes it skinny. 50 by 10 does that. Makes it flat. And 50 by 50 does that. Everyone to this point? You can try changing the color. I'll give you a couple of minutes to try changing the color on this. So if you set the red value and the green value to 0, it becomes a blue square. So any number between 0 and 255 is what gives you that.
I need help? You might behind your stuff. Raise your hand.
Please raise your hand. I do not want to leave anyone behind. You all want to see a cool party trick? Tell me like a pretty color that you like. Huh? Lavender. Lavender. So that's like a light purple, right? We'll say 180, 180, and then maybe 70 will give us a lavenderish color. Is that pretty good? Sure. Fuchsia is this actually. Thank you very much. That's a bit more of a fuchsia color. Anyone else have a color? I'm good at this, I'm telling you. Huh? What's a mauve? A brown red. Thank you. Thank you. So a brownish red probably looks something, it depends on the darkness of it, but I would probably say something like, 50, 10, 10. We'll get you that. Is that about right? Get rid of the black square. This is awesome. You just do that. Boop. Yeah, that looks. It's right. It's just the projector is telling you. It's the projector is screwing with the saturation, sir. I gotta know the name. How do I know you didn't just make up that name? You couldn't have said like purple. Like it had to be. So that's my party trick. Okay, so let's do something with this. So there's, I forgot to tell you a secret. This tick method doesn't run once. It runs very, very fast. Very, very many times in a second. In fact, 60 times a second. So to show that to you, let's try this. There's something called, there's a Ruby function called random, R-A-N-D, and what RAND does is it returns a number between 0 and 1. It's pretty cool. So, does anyone here suffer from epilepsy? Look away if you suffer from epilepsy. So what I'm going to do is I'm going to take this big rectangle, do that, and to prove to you that this function is running 60 times a second, I'm going to randomize the color.
Okay, let's turn that off.
Would you like me to keep going? Was that what I heard? Okay, so there's your epileptic seizure. Okay, pretty cool, huh? The color black is 0, 0, 0. That one's a easy one. Okay, so let's go back to our little tiny white square. And let's make the square move. Okay, so there's another magical property on args called state. So you can think of it, this is where all your stuff goes. Everything about your game, its properties, data, anything, all the things about your game goes on this one thing. Okay? We're going to set the x property to 0, and we're going to set the y property to 0. So this magical structure here, we call it the magic data structure, the MDS. It's a real term. It's able to accept any property you give it. It just works. You want to call it happy gaming? It will do that. And then what we want to do is we want to say args.state.x, args.state.y. So what we're doing is we're essentially coding on a tiny screen.
You missed the S.
I did, and I did it on purpose because now I get the error right here, right? I totally did not do that on purpose, but that's awesome. I can't count on audience participation, so my game tells me. And it puts you in the bottom right-hand corner. Okay. we're going to do one more fancy little thing with this equal sign, and we're going to put these two little, they're called pipes. We're going to put these two little pipes in front of it. And what these two little pipes mean, it says only set the value of x to 0 if it has never been set. Okay? Only set the value of x to be 0 if it has never, ever, ever been set. Okay, so we'll only do it once, even though this is running 60 times a second. And after that, I want to do args.state.x and add 1 to each one of the properties. What do you think is going to happen when I save? Oh, hopefully it starts moving.
There we go.
That is trippy.
I like that proof of it. It's running every 60 times a second better than the colors.
Yeah, I can make the square go faster, but now it's off the screen. So so what I want you all to figure out is how to get it back to loop back around. Okay? The hint is you have to use an if conditional. For those that haven't done any programming, you have to do an if statement. But I'll give you some time to figure out. Maybe try Googling something. We'll try. I'll let you flounder for about 20 minutes, or sorry, for 2 minutes, 3 minutes. And the way you reset the game, this part's important. Okay, because when you save the file, let's say you did it and it didn't do it right. What you want to do is on the game itself, you want to press the back tick, the squiggly line in the top left-hand corner, and that's going to bring down your console. Okay, and in here you type in $dragon.reset, and it resets your game. Right? So if you mess it up and it's somewhere in the random location of the screen, you can't find your square anymore, you can always do $dragon.reset, and it will reset your game every time. Everyone see that? All right, so try to figure out how to get this thing to loop. Okay. All right, time for the answer. This is how you get the thing to loop. So try writing that down and see if it works for you.
Can we pause for a second? You're going to catch up?
Yep. I'm just going to make it go super fast. And play around with it, right? This is what it looks like if you're going that fast. You can make it change colors. The way you reset, okay? There's a button on your keyboard. It's in the very top left-hand corner. It's tilde. It's the tilde/backtick. And when you press that button, this thing comes up. And then at the very bottom, you want to type in $dragon because DragonRuby, and then you want to type in the word reset, and then hit enter, and it'll reset your game. So this method is getting kind of big. Let's fix this. Okay? So we're going to try to chop this thing up into multiple methods so it's more manageable and kind of explains in a little bit better English what's going on. Okay? So the first thing we're going to do is we're going to create another method. We'll call it defaults. Right? You want to set the default values for a thing. And we're going to move code in there. And the next method we're going to call render. And we're going to move code in there. And the final method we're going to call is calc, for calculate. And we're going to put stuff in there. And then after we do all those things, we call all the methods. There we go. When you make this change, everything should act the same way. What I'm showing here is the evolution of your code, right? We start with everything in tick. It gets too big, so we move it around into separate methods that kind of explain what this thing does. So what does tick do? Well, tick sets defaults, then it renders, then it calculates. Default, render, calculate. Default, render, calculate. Forever and ever, ever. Into eternity and beyond.
The link to the webpage?
Yes, let me open up the link to the webpage. Eric's going to explain something.
Materials.
So tonight's materials.
All right. Make that up a bit bigger. Okay.
So we are right here.
If you get stuck at any point and you're like, this thing isn't working, all right, and you might have a typo, everything you're doing is on this page that's linked to from northdallas.net. So if you get
we are right
behind,
here.
you can copy that, paste it into the file, save it, and
it'll work.
you're back up to speed, okay?
Okay, and it has my notes in there too.
And so if you look up, you'll see the stuff we've already done. So
Right?
this is here so you don't get lost.
So we started here, then we went to this,
Yep.
right? Then we changed the colors, then we got it wrapping. That's the wrapping code.
And you get here by going to northdallas.net and click on that link we added 20 minutes ago.
So for those that are already to this point, try to figure out how to get multiple squares on the screen wrapping around. You're going to have to use something called an array. For those that are new to programming, don't worry. We'll cover it together. You might want to try to search for Ruby array to see how you create an array in Ruby. But you want to try to get multiple squares on the screen wrapping around. Because things are going to get really cool very quick after this one. How do you get multiple squares? How do you get 10 squares wrapping around? We got one square working. The question is, how do you make that 1 a 10 without writing all this code 10 times? Let's start dropping some hints. This should give you. This should also give you a hint of where we're taking this little application. So yeah, we have X and Y, but we're not going to use it anymore. We're going to create another list, right? So solids takes a list. Well, you can create a game state that's a list. Okay, so that's a hint. And so your render method will also change. Our background will stay the same, but instead of creating one square and updating its value, you're going to be making multiples of these and updating every single one of those values. Okay? Just small little hints. And your calc method is going to work similarly. We're going to take, instead of one value, we're going to iterate through all the values. Okay, so let's see what this looks like. What I'm going to do is I'm just going to put, we're going to start really simple. I'm just going to put 2 items in this list. A square at, there's going to be a square at 100, 100, and a square at 300, 300. It's going to be called stars. We're going to create some stars. And then, here, instead of doing what we're doing here, we're going to use a new capability that's available on lists. And this magic little thing is called map. What the word map means, it says, do this thing for every item in this list. And it actually works pretty much like English. You say do, you put the little pipe thing, you give your thing a name. So what I want you to do, we're going to call these stars. And for every star, we're going to get the X value, the Y value, set a width and height, just like that. So we have 2 stars, and don't worry, I'll keep this code up there. And we're going to do the same thing with updating the stars. So we're going to do args, state, stars is equal to ars, state, stars, dot map, do stars. I had errors, that's fine. Okay, extra comma in my array. So that's the cool thing with Ruby is that you can put trailing commas, and it's like, no problem. I know what you meant. You can put the trailing comma there. It's okay. We're still friends. Let's try this maybe. Did that fix it?
After you do.
Fine.
Why?
Why?
Comma on star Y. I might be wrong.
Star.y.
The one, that's what I
Ah, there it is. Okay, this comma.
I'm the best in this game.
There you go. I have 2 stars on the screen, but they're not updating, which is fine. We have to return. We have to send the star back. Did that work? Am I calling the calc method? What's going on? Why isn't this working? You see here, I forgot the or equal. That only makes only set it once. There we go. We don't need that. We totally need that.
stars in some places, star in others.
Yeah, let me explain the stars versus star. Okay? So stars, where it says stars here, this is the list, collection of stars. Let me get back to a working state. I had it working at some point. Was this it? There it is. Okay. So stars is the collection. These are all the values in the collection right here. Okay? When you type in map, remember map means for every item in this collection do this thing. Right? So at that point, I'm dealing with a single star. So what I'm saying here is, hey solids, or hey Ruby, what I want you to do is go through all the stars, and I want you to take that value and instead give me something that represents the XY position of the star, give it a width and height and a color. Okay? So that's why sometimes it's plural and sometimes it's singular. Because after you map, you're saying, I want to deal with each thing one at a time. Okay? But I agree. Typing star over and over again is not fun. So the interesting thing is these array elements can be, it's a special term, it's called destructured. So you can destructure an array element and just say, what I want to do is map over all the array elements, but I just want the array elements to just point to each one of these. So if you've got 2 elements in the array, the first one's going to go to X, the second one's going to go to Y. And by doing that, you get this. right? You get rid of all the repetition of the star. And you get that instead. And you got to get this one, rid of this one too. So I got rid of all the repetition. So for those that are already caught up to this point, make this a little bit tinier. And again, play around with this. See if you can get this with multiple. So for those that are caught up, I don't want to. If I want to create, let's say, 100 stars, I don't want to have to type 100 times random locations, right? That's way too much work. So how would you update this line to not have to type those random locations? Another thing that you want to try, again, if you're caught up, is the color is always white. Well, what if I want a color assigned to each star when it was created? So how would you change this code based on what, for the experienced programmers, based on what you know, so that you get a color assigned to each star, and you can assign multiple stars without having to type them one at a time? How would you do that? So I'll give you all, say about 5 minutes for those that want to catch up to this point to catch up, and for those that want to get ahead to get ahead. And remember, you can always reset the game by hitting the tilde key, typing dragon.reset, and it'll reset your game. Okay? Does anyone have any questions in general? It doesn't even have to be about the game engine, just stuff.
I'm kind of curious, actually, how you would make it bounce off the top of the screen instead of like, I know that in this case we're trying to make a stars environment.
Right.
Earlier I tried to make it bounce off the top and it did not happen.
Okay, so the question was, well, this is cute and all with the wrapping, but I wanted to bounce off a location as opposed to just wrap around. Well, at that point, what's required is this right here has to be conditional to the direction that it's going. Right? So you instead of setting it to 0 every time, you have to basically give a direction. So you have to say, so you need to have x, y, dx, which stands for delta x, delta y. And then when this hits 1200, you set the delta x. In fact, well, the question was, the comment was, well, can't you just change the 1 to a -1? Remember, this thing runs 60 times a second. So how many times do you want that -1 to be a -1?
Whenever it reaches 1280 or 720.
That's correct. So yeah, so when it reaches one or the other, that's correct. But then you have to hold on to which direction it's going for the next frame, because you're going to lose that information. So you have to keep track of that information with every frame. Okay? So actually, there's an example of this inside of DragonRuby. So we'll take a small little detour, and if you go to samples, there is a sample in there called simple collision. You want to go double click, go to samples, and take a look at simple collisions and controllers. There's going to be a file in there called watch recording. If you double click that file, it's going to run a demo that I pre-recorded for you. This happens to be Pong, playable with the controller that I recorded previously. But this, as you can see, the ball bounces off the top and bottom. And if the source code's right there. So you can look at the source code, you've got the replay, and if you've got controllers, you can hook up your USB controllers, which I have, by the way, if you want a controller. You can hook up USB controllers and play Pong with your friends. But the sample app shows you how to retain the direction, and it shows you collision with rectangles. You are welcome. Okay, so let's make lots of stars. the way that works is instead of setting it to an explicit array element, we're going to use another map. So I'm going to do 10.map. So apparently arrays have maps, and so do numbers. And what we're going to do, we're going to say, all right, well, we're going to use random, and we're going to say we want a random number. Remember, random returns 0 or 1. It's a percentage. So if you take a decimal value between 0 and 1 and multiply it by a whole number, you get a percentage for that number. That's how it works. So I'll say I want a number between 1280 and 720 10 times. After that, I want to reset my thingy, and I have 10. That's all. That's it. That's all you had to do. Now, let's say I want to change the color too. Okay? Same thing here. We'll set it to a random value. This is not going to cause an epileptic seizure because we're only doing it the very first time. Remember, that's why the or equal is there. And we're going to use our destructuring concept. Red, green, blue, to generate our colors. And then reset the value. Everything's terrible. Didn't work.
That's what happened to me.
X, Y, red, green, blue. Because you have to return the values. You set it the first time, right? But then you have to return the values back because you're recreating the array every time. See that? There you go. We got random colors. Remember, what map does is it says, I'm going to go through each one of these items and I'm going to give you a new item. So if you don't keep your color, it'll go away. Maybe set it to 100. Let's see what happens. There you go. We got 100. So this is kind of cool because if you forget the or equal, you're setting your star location randomly every time, 60 frames a second. So you get almost TV static. It's kind of cool. And I could even do this, right? Because this is happening at 60 frames a second too. Now my TV static's at random sizes. I can go even crazier, make them really big. This is the beauty of experimentation live, right? You make a mistake, but it ends up being who's that one guy that's like, this is just a happy little mistake that we made? Yeah, it's just a happy little mistake.
It's now a bird.
Yeah, I forgot.
Bird's down.
I forgot the or equal, and suddenly I'm like, oh, that's a cool little effect. Let's explore that. All right, so let me get y'all caught up to this point. This random stuff that you're seeing here. So there's a zip file on that site, and it's got images in there, and you want to bring those images down. Let me make these a little bit larger for you. There you go. There's just like one orange orange square that's like, I'm cool. I'm just going to be chilling. Why is that one square just kind of like, ah? There we go. That's the effect that I wanted. There we go. So I made one more change. Not only did I randomize the starting color, but I randomized the speed. So instead of every single square running at the same speed, the squares now move at different paces. And what that gives you is like a really nice parallax effect. Do you see that? So the cool thing with colors, let me kind of elaborate on this rand usage. Okay. So here's what you need to do with the files that you downloaded. So you remember your My Game directory? What you want to do is you want to create 2 folders. Or you want to move the zip files, the zip file when you open it up, there should be a folder called Sounds and another folder called Sprites. You want to put both of those folders inside of that same My Game directory. Right? So you should see app, sounds, and sprites, and then in your app directory is where main.rb is, right? That's what you should see. Download the zip, unzip it, sounds, sprites, My Game folder. Yeah, so the question was, is there some way to spit out a variable value mid-program? The answer is yes, and it's puts. So when you type puts and you go to the console, you'll see it show up however many times you put it. Okay. So I'm going to introduce a new concept for you. I want to just try to get an actual sprite showing on the screen, a PNG of some type. Okay? So this is the first time we're using something that's not a solid. There's another data structure in outputs called sprites. So we went from using solids and we changed it to sprites. Sprites takes in a few more parameters. You have the x and y value, the width and height of the sprite, the location of the sprite. This is why you had to put it in the My Games directory. This is the rotation of the sprite. Since this is a square sprite, setting it to 90 degrees is not going to do anything. This is the opacity of the sprite, and then red, green, blue. So this is kind of how the evolution of games work, really. You start with just these arbitrary shapes. You try to visualize the aesthetics of your game, what is it going to look like, and then you start putting in detail. The last thing I want to do is worry about assets, PNGs, and all those things when I'm just trying to figure out how my game's going to feel. So we got the colors working, I got everything looking good, and then I went, all right, I'm going to bring in an actual PNG into the mix. And this is our sprite right here. The sprites folder should be, that's a good question. The sprites folder, so you have your My Game directory. There should be your app folder, and your sprites folder should be a sibling to your apps folder. Okay, for those that are caught up, there's a sprite in there called sun.png. Put that in the center of the screen. Try to figure out how to put that in the center of the screen. And there's assets actually called Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and the planet formerly known as Pluto, or the Pluto formerly known as planet. So with regards to this approach, this idea of continuity of design is exactly this. It's small changes to get to the next point of complexity. I started with solids. I started with just X, Y points. Okay, destructuring works. I want to include speed. I want to include color. I want to include randomization. I have a feel for what my game will look like. And then I want to transition that and actually put visuals in there and bring that into the fold. And this continuity of design is important because most of my games don't have many files. My entire games do not fit in one file. Some of my games are over 20,000 lines of code. They do not go in one file, but they all start that way. And the decision I made with regards to this game engine was to maintain that continuity of design, because the way I began is just as important as the way I ended. So if I built a game engine that only captured the way I ended, it would be really difficult for someone that is new to the engine to come to it and set up a game environment. Because the entities are much more complex than these list and destructuring concepts. I have classes, components, algorithms, all those things end up happening. And if I force someone that has never done any programming or has never done Ruby to start at that point, saying that you have to create this complex structure to just get something to show on the screen, I violate that continuity of design. So it's really important to me to make sure that you can make these small changes as you build out your engine. And I feel like a lot of the frameworks in this day and age, they fail at that. They give you the final perfect enterprisey structure or fully optimized layout, but it's not approachable from the very beginning. See what the sun looks like? That is all the code, I think. Yeah. Start with defaults, create your stars, create your sun. We have a method here that can center the sun in the center of the screen. You've got your background. You've got your sprite that represents the sun. We're following on the right buffer now. And then we actually call the toSprites function. We move our stars. We don't have to move our sun. And our render method does defaults, render, and calc.
What is that R function? I mean, I see it calls DragonReset. Is that a shortcut for triggering a reset?
Yeah, so the question was, what is this R function? Is this a shortcut for triggering the reset? The answer is yes, because I got tired of typing $DragonReset. So now I can just type reset. I can just press R, and it resets it. So anything that you write in the code is accessible through this point, right? So if I want to see the exact location of my stars as they exist right now, I can do $dragon.args.state.stars. Those are my star locations as they exist at this point in time. X, Y, speed, red, green, blue. Where's my sun? There's my sun. It's an entity. But it's kind of how it works. So this is the entity object that I was talking about, where arrays are okay to a point, but eventually you want to create something that's real. And this works the same way as the game state, except it gives you another thing to hang stuff off of. So we have our defaults. We create our sun, set it up as an entity type, which we're doing right here. The or equal, again, this pipe equal operator means only do it once. We create our sprite. We have a little helper method to center a sprite. And then for our render, we set the background, we set the sun, we set the stars. Our calculation does what it always did. Let's move the stars around. Wrap them around the screen. And then our tick method sets the default, renders, and calculates. So we're looking at about 50 lines of very wrapped code, trying to fit it on a very small screen. But about 50 lines of code to get a nice little scene of stars and a sun in the center. So to wrap up, again, all this code is available for you through that zip file. Okay? There's a final version that's in there. And these are essentially all the concepts that you need to build out an entire solar system. Okay? Let me show you what that looks like. And I've added some sound also, so we're going to get to hear the sound too. Here's your solar system, and here's your music. I'll take one of my USB controllers, just plug it in. There we go. We got a little ship flying around. Ship's flying a little too slow. I can fix that. I've got the ship speed just at a vector. Let me maybe set that to 5. Save the file. There we go. It turns kind of slow though. Let's change that. What's our turning angle? 1 degree. Let's change that to 5. Alright, there we go. Oh gosh, I'm off the screen. I have no idea where I am. Wait, crap. That's okay. R. I am. So one thing that's really interesting about the solar system, this is Earth right here. And I've set its time scale to where every frame, which is again 60 frames a second, every frame is 1 day. So after 365 frames, it's back at its year. So the interesting thing is that Jupiter's rotation speed, or its orbit around the sun, is actually about 12 years. So if you pretend the Earth is the minute hand and Jupiter is the hour hand, you kind of have like a solar system sized clock running around the world right now. I'll show you one more game. Well, actually, just real quick, at the root directory of your little DragonRuby application, you will see something called DragonRuby Publish. And what this will do, after you've built your game out, you want to go to itch.io, itch.io. You register for a username, and when you double click that button, after filling out some login information, there's going to be a file inside of my game. It's called metadata. This file here, you just put your username and the name of your game in there, and it will deploy your game onto itch.io. So the way the deployment works, I'll show you one of our games that we've deployed. Of course, we have to create Flappy Dragon. And what it's going to do, it's going to deploy the Mac, Linux, Raspberry Pi version and Windows version, and an HTML5 version that you can play in the browser. You just have to double click it, the publish button. And this is quite literally playable in the browser. There you go. This game that you're seeing here is actually a sample app that you can look at. If you go to the samples directory, you're going to see a sample app called Flappy Dragon. And let's go in and watch the recording. Let's close that. Close. Let's watch a recording of this and see what it actually does. Yes, open.